So hello, everyone. My name is Jinhui Qin. I'm one of the HPC technical consultant at SharkNet and cited at Western University. So today's topic is working with the Jupyter on clusters. If you work in data analytic field, Jupyter Notebook should not be new to you. It provides a web-based interactive environment for notebooks and code development. It is commonly used in data analytics, for example, to visualize data, to test a code block, to measure the runtime of a code block, or to document the code for writing self-explained tutorials, and etc. So with additional kernels and add-on extensions, Jupyter supports different programming languages and application tools. For example, not just for Python, you can also work with R in RStudio through Jupyter using a web browser, or work with Julia or even C++ after adding those kernels and etc. But in this webinar, I will only focus on the options for working with Jupyter in Python on the national clusters. So the common way to access the computing resources on the clusters is through SSH, a secure shell via command line on a terminal. And the jobs to run on the cluster are requested and managed through a Slurm job scheduler. Since Jupyter was implemented as a web application, which is connected using a web browser. So in order to make use of the compute resources on a cluster, a notebook server needs to run on the compute node of a cluster. However, on most of the clusters, there is no direct internet connections on a compute node. Before you are able to connect to the notebook server using a web browser, usually you need to set up a secure tunnel through a logging node between your local computer and the compute node that runs the notebook server. Thanks to our cluster team for making a JupyterHub available on each of the clusters. That makes it much easier when working with Jupyter on a cluster. A JupyterHub provides an additional option for users to access the compute resources on a cluster simply through a web browser instead of through SSH on a command line. Working through a JupyterHub using a web browser is convenient and more user-friendly, but still there are some cases that need more consideration. So in this webinar, I will present the options for working with Jupyter on clusters. For example, when to consider using a JupyterHub. Is it enough to work with a pre-configured environment through a JupyterHub? Is it possible to work through a JupyterHub, but with a Python virtual environment that you created in your account? So when to consider using a command line option? For example, how to work with a commercial software package or how to work with a container-based package and etc. So I will provide some general suggestions and demonstrate the several use cases with instructions on the cluster. So let's get started. So here is the outline. First, we will have a quick look at the notebook interface. You heard about Jupyter Notebook a lot. You might also heard about Jupyter Lab in recent years. So what are the differences between them? Then we will go through the procedures for launching a notebook server on a cluster. As has been mentioned, there are two options. So one is through a JupyterHub, the other is through a command line on a terminal. Because for some use cases, it is still unavoidable to use a command line option. Some cases might need to combine both. I will demo these through several use cases. So for use case one, I will just demo how to run a notebook through a JupyterHub without using a command line. The example notebook is for image classification using TensorFlow on a GPU. So for case 2, is to work with a package called Groovy, which is a commercial software suite for solving some complex optimization problem. And it is available on the cluster. So to work with such a package in Python, it requires to build a Python virtual environment and have the required Python API installed. This case is to demonstrate how to run a notebook with a virtual environment that you created in your account, either through a JupyterHub or through command line. So for case 3 is for working with a container-based package, because some Python packages are only available through conda install, while conda or mini conda is not recommended to be directly installed on the clusters. And also some packages are too complicated to install because of some complex configuration and the dependencies. And usually it is available as a container-based package, for example, through a Docker image. But all these can be supported on the cluster by creating a singularity container image. So you can then work with such a container-based package with Jupyter on the cluster if needed. I will demo such a case, and it can only be done through the command line, not from JupyterHub. Okay, let's first take a look at the differences of the two types of notebook interface. On the left side here is the classic interface called the Jupyter Notebook, the original web app for creating and sharing computational documents. It provides a simple and document-centric interface. On the right side here is the new interface called the Jupyter Lab. It has a more flexible interface with a modular design to allow adding extensions to expand and enrich the functionality. So both are web applications for notebook rendering. No big difference on the notebook panel. For example, you can add a markdown cell for writing those texts in a format, and also add a code cell for writing code and run a code block. Okay, so on the classic interface of Jupyter Notebook, you may notice that the menu bar is all on the top. So for example, you can click such a file to open the file menu if you want to locate a file in your account. So on the Jupyter Lab interface, there are multiple panels you saw here. The menu bar is on the top, but there is also a sidebar here on the left with some icons. Those icons are for accessing add-on tools. So for example, you open this browser icon to open this file browser to looking for a file in your account. So this blue icon here, I believe, is for open the module panel. So you can have a look at what module currently are loaded and looking for any other module if you want to load or unload. Yeah, there's a module panel as well. So there is a launch panel here. I didn't show in this. It's for launching different applications if added. For example, if you load the RStudio, if you have our server module loaded, you will find the RStudio icon on that launcher panel to load the RStudio. Okay. So both interfaces are available and can be selected to use on the cluster. But it is recommended to use the Jupyter Lab interface as it has a clean look with more functionality. So in the demo later on, I will also select using the JupyterLab interface. So the functionality are the same, just different interface. This is the traditional Jupyter Notebook. This is the new interface called the JupyterLab. Okay. So to make use of the computer resource on the cluster, the first you need to do is to launch a notebook server on a cluster. So let's first take a look launching a notebook server through a JupyterHub. It is provided as a web portal that you can log in using a web browser. So once you click a JupyterHub link on a cluster, you will get to this login page using your Alliance account credential, the same one, the same username and password you use to log into a cluster. After you log in, you will get this server option pages. It allows you to specify your request, similar as what you usually request in a Slurm JavaScript. As you can see, you only need to use a web browser to log into such a web portal to start a notebook server once you have this resource request filled up. So there is no need to write a Slurm script to submit in the command line. Okay. Here is a link to the wiki page that has the link to the JupyterHub on each of the clusters. So depending on which cluster you prefer to work on, you can click that JupyterHub link on that cluster. Another option is to manually, through a command line, launch a Jupyter notebook server on a cluster. Through the command line, first thing you need to do is SSH to a cluster that you would like to work on. And then you need to create a virtual environment. For example, you need to load the Python and any other module you would like to work with. For example, if you want to work with NumPy, Pandas, Matplotlib, those commonly used the library, you might also want to load the SciPy stack module because it includes many commonly used Python packages and any other module based on, depending on what package, what application you work with, okay? And then you create a virtual environment. In this virtual environment, you need to install JupyterLab if you would like to work with the new JupyterLab interface and any other additional Python package to this environment. Once you have such a virtual environment created, the next thing to do is to request an interactive session on a compute node. For example, with this slog command, you specify your user account, number of CPU core, the memory size. If you need a GPU for this notebook, then you need to include that request as well. So, and also the time you needed for running this notebook server. Once your request is located on a compute node, you will automatically switch to this compute node. And then before you activate your virtual environment, you need to load all those modules that you needed. So any environment module needed, you need to load them before you activate the virtual environment. Then in this environment, you launch JupyterLab by running this command. Okay, this is the way to manually launch a JupyterLab on a compute node in an interactive session. Okay, After we show the two options for starting a notebook on the cluster, let's compare the features supported by each option. And that might help us to decide which option to go. So here are the general features that I listed in this table. The first thing is for connecting to a notebook server. If using the JupyterHub option, you will automatically connect to the notebook server on the same web browser once the launching process is completed. If launching from the command line, before you are able to use a local web browser to connect, you need to set up a secure tunnel between your local computer and the compute node that runs the notebook server. So that could be a drawback of using this option because of this additional step. The second feature is for the default environment. For the JupyterHub option, the environment is pre-configured. So the default location for installing any additional package is configured on the local scratch disk of that compute node, so which will be purged after the session is done. So the environment is temporary. This could become a drawback if you prefer to work with a persistent environment without having to install the required package every time when you start a new notebook session. But for the command line option, as the virtual environment is created in your account yourself on a cluster, right? As long as it was created in your home or project space, it is persistent in your account with all the packages that you installed. So the next is for the internet access on the notebook. The answer is no for both cases, because this notebook server is running on a compute node. For most of compute node, for most of the clusters, there's no direct internet connection. So that means you cannot pull any data from external during runtime on a notebook. It will fail because no internet access on the node that runs the notebook server. Instead, you need to pre-download any data if needed and make it available in your account on the cluster. So then you specify the path to the data instead of pulling from external. So for accessing any files on the cluster, the answer is yes. So there is a file panel on the Jupyter Lab if through the JupyterHub, and also yes, the same thing, yeah, if you're using the Jupyter Lab interface, okay. For installing any additional package, the answer is yes for both options. But for the JupyterHub option, you can only install those pre-built on the system warehouse, because there's no internet connection on that notebook interface. If you want to do pip install on a notebook cell, you can only install with -- no index to pull any that is available on the system. You cannot install anything from external. But the answer is yes if using the command line, because the virtual environment is located in your account. You can always access on a login node that has internet connection, and then you can install any package you needed on the login node. So to work with a self-built virtual environment, I put possible here for the JupyterHub option, because there is some additional steps for adding a customized IPy kernel to make it available to a notebook server. So it needs some command line step. So I will demo this in a use case shortly. So for the command line option, the answer is yes, of course, as everything is installed in a self-built virtual environment, right? So using module, the answer is yes for both cases. So there is a module panel if go through the JupyterHub option. And if you launch a JupyterHub, you install in a virtual environment through command line. Yeah, before you activate your virtual environment, you can always load any environment module on the system. So you can have those packages available when you run the notebook. Okay. Using GPUs, the answer is yes for both cases. So yeah, on the server option page, if you need to use a GPU, you can always select a GPU on that cluster before you click the start button to start a server. From the command line option, with that salloc command to request an interactive session on the compute node, you can always include the GPU request if you would like to use a GPU. And work with a container based package, the answer is no. So you have to go through the command line option. But I will demo this case shortly. So hopefully I list the most, if not all of the features for working on the clusters with these two options. You may use this table as a reference to decide which option to use for a specific case. So in general, working through a JupyterHub is straightforward. The graphic user interface through a web browser is more user-friendly, even if it requires to combine some command line work. For example, for this case, to work with a virtual environment. But that's not too bad. So, but if you are comfortable to work on a command line, as you can see from this table, the command line option is flexible in supporting all cases, but extra steps are required. Okay. So now I will start talking about the case one I'd like to demo on the clusters. So for case one, it is to run a Python notebook for image classification on GPU. So we're gonna launch a Jupyter Lab on a GPU node from a JupyterHub and working in such a pre-configured environment, load modules, for example, SciPy Stack for using NumPy, Panda, Matplotlib, and also install some additional library because this notebook is gonna use a TensorFlow deep learning framework. So we're gonna install this package as additional to the SciPy stack. And yeah, we can also upload, download, or export files on the notebook interface. So in this demo, I won't use any command line for doing any work. So let's have a look. This is the wiki page for JupyterHub. Yeah, you can find it here. Here is a table to have the link to each JupyterHub on a cluster. Let's try with this option. So this is the JupyterHub on Gram. So you put your username, password after you log in. You will get to this server option page. So for this demo example, I will use a GPU. So you can click here to select account that you have access, but with the GPU, since you're gonna use a GPU. Yeah. if you need to use GPU. Otherwise, you use that CPU account, okay? And then you specify number of cores and the memory you needed. Yeah, here is a list of GPU that you can select. I will request a 1 T4 type GPU. For the interface, as you can see, I selected the Jupyter Lab interface. The old interface is also available. There is a third one called terminal. That's for if you want to simply work through a terminal using a browser instead of SSH, then you request that terminal. But for this demo, we are going to work with a notebook, Jupyter Notebook. So I will just use this one. So maybe I put 1 hour to see it will go through quick. Yeah, once you click start, it will send the request to the Slurm queue on a cluster. So this will be located on the Gram cluster. You see, once the process is, the launching process is done, you automatically loaded this Jupyter Lab interface. Okay, this is the launcher panel. Here is the file browser panel. You can click to hide and open this file browser. And yeah, so I have some notebook in this folder. This will be the home directory. So I have some demo for case 1. Okay, let's open this one. Okay, in this notebook, it's a notebook from one of the workshop for deep learning from NVIDIA. Okay, I'll just use it as a demo here. So for example, if you run this cell, it says NumPy, the module NumPy, there's no such a module in this default Python kernel. So we know the SciPy stack has NumPy module. So here, if you click this icon, it will show the modules. So these are the currently loaded module. The default is a Python version 3.8. Okay. So if you want to looking for SciPy stack, the search field here, you type SciPy stack, you will see the available module showing up here. So I will just load this one. Okay, so you see this is loaded. Okay, once it's loaded, you can try this again. If it still says it's not available, then you will need to refresh, restart the kernel. Yeah. Usually you need to restart it once you have anything installed. So then we can run this again. You see, it's loaded. So you can use any package included in SciPy stack. Okay. So yeah, this is the notebook panel, and we can have this. So I might enlarge a little bit here. So you can always add a cell. For example, this is default is a code cell. You can make a markdown cell if you want to, for example, write some text. This is a title. And with some bullet point. 1, 2. If you run, because this is a markdown cell for writing text, so it will give you this kind of format. So that's the way you're adding some document in a notebook. Okay. By default, once you add a cell, it will always be a code cell, but you can change it. Okay. So we will run this notebook. I won't go any detail to about this notebook because we know we're gonna use a TensorFlow. So we need to install TensorFlow. So before you are able to run this, okay, if you run, it will say no module named the TensorFlow. So you can add a exclamation mark in front of any like shell command, pip install with -- no index for this TensorFlow package. This specific version. It's available on the system. Let's click. So yeah. Put an exclamation mark in a shell command, you can run it on a notebook cell. So it will take a while to have it installed. Okay, it's done. Once it's done, you see a number showing here. So this number actually showing the order in which a notebook cell is being executed. Okay. So we rerun this command, but you need to, because this is just installed, you need to refresh the kernel. And then run this cell. You see, it has the TensorFlow package imported. Okay, the minutes set is imported. So once you refresh a kernel, you see everything you run before, it's gone. So this will become the first cell you run. Okay, just make sure anything you needed, you need to rerun it if you're gonna use it. Because I know in this notebook, I only need to use this. So it doesn't matter whether I need to run any previous cell. Okay, yeah, as I mentioned, for this data set, if you didn't provide the path, it will pull from external for the minister data set. So I pre-downloaded from this location, get it into my account. So I can just run here to load the data, and then you can see the shape of the training data set that contains 60,000 images, and each is 28 by 28. It's two-dimensional. That's the validation data set, has 10,000 images. And you can check a data type and also the minimal value and the maximum value. It's a grayscale image. So the value is between 0 to 155. Okay, you can also, oops, run this cell to get a picture shown. Yeah, that's one of the functionality you can visualize your data on a notebook. Okay, and here just reshape to prepare for the training. You turn the two-dimensional 28 by 28 into one-dimensional, that is 784. Okay, so yeah, you just run this cell. So like you go through a tutorial or something to learn by yourself. So that's the convenient way. So since the minimal data is The grayscale is between 0 to 150. So here, just normalize them, make the value between 0 and 1. So next is to do the category encoding. So yeah, I will just run the cell without go through the details. So, but one thing I would like to show here, since we have a GPU requested for running this notebook, so you can actually checking the GPU status. So using this NVIDIA -SMI command with exclamation mark in front. So you see, this is a T4 type GPU. Right now, there is no data on the device, so it's 0 showing here. For TensorFlow package, if you create a model, it will automatically detect whether a device is available. If it's available, it will locate it on the device. For example, here, once you create such a model, a sequential model, it says it's created on this device. Okay, so if you check the device again, you see it has this much of data located on device because the model is created on device. And for the rest, it will just adding more layers to this. I won't go any detail. I'll just make it run with all below. So it will all run, connected run. And now it's going to this training cell. Yeah, this example just demonstrates you can work through this JupyterHub on a GPU node to install any additional packages and load the system modules. Okay, once you're done, you can save it. Okay, and then I will close this. And you can click this icon to check the running kernel, because I already closed it. I want to shut down this kernel for next example. So, okay. Yeah. Okay, let's go back to this. This is the first case. Yeah. So I want to show here. See, here you can use this browser panel, file browser panel to upload any file from your local computer or download. You can select a notebook, see, to right click to download or export. Yeah, there is a save export. Yeah, if you want to export any files. Because I already closed that. So once you have it open, you can have all those options available for your selected file. Okay. Okay, now let's go to the second case here. So this case is to demonstrate how to run a notebook with a virtual environment that you created in your account, either through a JupyterHub or through a command line. The example is to work with a commercial package called Groovy. We have a wiki page for Groovy. It is a commercial software suite for solving complex optimization problem. So to use this package, you need to submit this form to get access to the license on the cluster. So yeah, before you are able to use it. It has details for how to work with, but not any detail for working with a Jupyter Notebook. So the example notebook was from, let me show you here, was from one of the modeling example from Groovy. on JupyterHub. Not for JupyterHub, on GitHub from Groovy. Okay, in this example, yeah, the goal is to assemble a best team for a basketball game. A basketball team typically consists of 5 players, right? So each player plays a specific position. So to measure the performance of a player after a game is completed, there's a formula that can be used to calculate so-called a fantasy point of each player in a game. Then given the historical data of the previous games for all players, with a machine learning model, you can predict the performance point of each individual for their next game. But to create a best team to play in a coming game season, for example, the players are not simply picked based on their points from a machine learning model. You will also have some other constraints, for example, their position constraints and the total salary cap with the given budget, right? The higher points a player has, the more you need to pay, right? And each player can only play a certain position. So this example is to demonstrate how to combine machine learning and the mathematical optimization using Groovy. So to work with Groovy in Python, as I mentioned, you need to create a Python virtual environment and have their Python API installed in the virtual environment. So back to here, I list these steps. These are the details for how to create such a virtual environment, yeah, after you activate. But first you need to load this module, okay? Then here is the command to install the Python API for using Groovy. And these two are the additional package that needed. If you look at the notebook here, it says it need to use these packages because we know a lot of them in the SciPy stack module. Yeah, so these scikit-learn and the Seaborn you also need to install. Okay. So there are 2 options for launching a Jupyter Lab. The first the one is through JupyterHub. The other is command line. So let's first take a look at the option 1, launching from Jupyter Lab. I was still using the Jupyter Lab I used here, but we need to add a additional IPy kernel from a command line on the cluster in order to work with that virtual environment. So here are the 2 commands that you need to run in your virtual environment on the cluster for adding such a kernel. Okay, let's do it here. Okay, this is okay. Let me. Okay, this is a terminal on Gram. Okay, I will go to PWD. Okay, project. It's in Jupyter demo and the CD. Case 2. Yeah, I already have such an environment built. So before I activate that environment, I need to load Python, SciPy stack, and the Groovy. And then I source Groovy to activate the environment. So I need to install the IPy kernel and also add this Groovy. Okay, so I would like to make this showing here. You will see what it's gonna look like once I have this IPy kernel installed. Index IPy kernel. Yeah, because this is environment is located on project. Yeah, okay. Now the next is to install, add that kernel called install -- local. That's for install such IPy kernel in your local account on cluster with a name. If we call it same as the environment name, okay. Didn't type it wrong, right? Oh, there's the arrow. -- local, it's not local. Let's double check. User, sorry. User for install in a user a local account. Okay. Okay, it has it installed. We will see here, it will show up additional kernel here. It takes time to load there. But if you using Jupyter kernel spec list, you will see the additional kernel is showing here. You see it's available here. So this way you are ready to use it on the Jupyter Lab, okay? So let's make it bigger here. So I would like to go to case 2 to locate this notebook server. But as I need to load the Groovy module as well. So before I run, I need to find the Groovy module. Groovy module, it is here, so I can load it because I already have a SciPy stack module. Once I have those module needed located, and then I go to here to find the notebook that I downloaded from that GitHub. So you open it. See, once you open it, to make sure you are using the Groovy kernel, because if you check this list, the default one, there is the another one is the Groovy. And if it's showing as the default one, you need to switch to this environment. It has the Groovy interface available, okay? And then you can run this notebook. Yeah, I won't go any details to run this. You can use this magic command to see this notebook is located in this directory on the cluster. You can also looking for files. But on this interface, you have such a file browser, okay? So these are the packages needed. You need to import them. So the last one is the one from the the virtual environment that we have installed. Yeah, because to initialize the environment, it took a while. See, once it has everything installed, you are ready to run. Go through each of the steps to run this cell. Yeah, I will just run all of them at once. Won't go any detail about the contents. You see, you have some visualization of the data, and then yeah, see, these are all the data. Yeah, this is a way of still running. This is the calling the machine learning model to predict each player's score or their fantasy point. Yeah, this is a way how to work with a virtual environment that you created, but through the JupyterHub. Okay, yeah, you have all the cell installed. This is just a message, remind you some function deprecated, but that's fine. So yeah, you see, you can run the entire notebook here. Okay. Okay. So this is the option 1 for working with this JupyterHub. So I think I don't need this notebooks. I can just delete it. So I close this. I go to here to turn off this kernel, and then you can go here to go back to the hub control panel. If you're done, you stop the server. Yeah, then you log out. Okay. Then we don't need this. We don't need this. Let's go back to option 2 is launch a notebook from a command line. So for this option, you need to install JupyterLab in the same virtual environment if you would like to work with the JupyterLab interface. So here are the steps. Yeah. You do this install on the cluster, because this is to show the option from the command line. You request a interactive session on a compute node. Once you are on the compute node, you load all those required modules that activate the environment to launch JupyterLab with this command. Okay. Once it's successfully launched, you will find such a URL for the notebook server. Since this is on the compute node, right, you need to set up a SSH tunnel on a second terminal from your local computer. So leave this terminal running without closing it, and then you open a second terminal, run this command to set up the tunnel. So here is the part, the host name of the URL and the port number for running that notebook server. So here you use SSH-L with a port number on your local computer that you selected. You can use the 888 as well, but I will just, for differences, I choose 999. And then you need to go through the login node of that cluster. So you just put this. After you enter, after you click the enter key, it will ask you to type the password. Okay, once you are logging set up this way, leave both of the terminal open and running without closing it. Okay. Now you are ready to open a web browser on your local computer, but with these URL. So instead of type the original URL, you switch it to localhost 9999, as I already forward the port on that compute node to the local port 999. And the rest will be the same for the token. Okay, so this way you will be able to connect it. Okay, I won't demo this for the case 2, but I will demo similar in case 3, because case 3 you have to go through the command line. Okay, so here is the case 3. To run a notebook using a container, as long as the Jupyter Lab or Jupyter Notebook is included in a container, you can work with such a container using a notebook on a cluster. So to demonstrate this case, I have 2 examples listed here, but the first one is for working with a rapid through a singularity container on a GPU node on cluster. Okay, if you click this link, we have a wiki page here, detail the instruction for working with the GPU through this container with a notebook. I have detailed the instruction available on this wiki page. I also had a demo in my previous webinar. The video recording is available if you are interested to watch the demo on Gram for using a notebook with this container. You can go to SharkNet YouTube channel. I think it's around 38 or 39 minutes of this video. The demo starts there. Okay, but for today's demo, I will just using a Anaconda container. It is built based on Anaconda Docker image from JupyterHub. Yeah, you can build Anaconda singularity image on the cluster. If you want to look details for singularity on the cluster, we have a wiki page. You can go through this wiki page for any detail how to build such a container. You may have known that the Anaconda contains more than like 400 Python packages for data science. I have to say that most of them are probably available on our clusters. So you can simply use pip install to install any in a Python virtual environment if needed without using a container. But this container, I know it also has Jupyter Lab included. So for simplicity and the demo purpose only, I will just use this container to demonstrate how to start and connect to a notebook server from a container through the command line. So here are the steps. The first thing, you need to request a interactive session on a compute node. Yeah, similar as any other you want to do manually launch a notebook server. So then the thing you need to do is to load the Singularity module. The latest version is called Uptanner, but the functional same, okay? And then access the container shell through this command to bind any file system to the container so you can access any files from inside the container. Once you are in this Singularity shell, so as you can see, you only need to load the Singularity module, okay? Then you launch Jupyter Lab, the similar as I showed you to launch from a virtual environment, but this is from a container shell. Same thing here, you will find the URL of that notebook server and then set up the tunnel for connecting. Yeah, leave both terminal and then connect with this. Okay, I will bring up the terminal again here. Okay, as I already have, as you can see, I already have such an interactive node reserved before I start this webinar. So this is on a compute node on Gram. So this is my current directory. I go to case 3. Okay. I do a module load singularity. And then I do singularity shell to access the shell, but I need to bind my home, or maybe bind my, this is the project. So, and then I will get the anaconda image. Okay, now I'm in the container shell. For example, you can check the Python version, and then I have conda installed. So conda list, you can grid Jupyter. Yeah, so I have Jupyter installed. If you want to check how many packages actually included in this container, it's more than 400. Okay, you can see the root in this container is different from the one on the host. Okay, these are all working inside the container. So now I'm going to launch Jupyter Lab with no browser. IP, I want to show what this the IP. Okay, so this is the IP URL for running that notebook. We need to copy those, open a second terminal to set up the tunnel with the port. I will select this port to forward this port, but through the login node. This is gram. Okay, so for staff, we request a second authentication. So I will type my code. Yeah, for any general user, you only need to type your password. Okay, so once I have this tunnel set up, leave this open. Okay, so now to connect to this notebook server, I need to copy the entire URL. So let's bring back to open a new terminal here, a new browser here. You type that URL, but you need to change this part to local host 9999. This way you connect to the notebook that runs on the compute node, because you already have this Groovy kernel added in your account. So once you have this notebook started, you also see here. So I don't have any notebook to run through this container. We probably can create a new, just using the default environment, a default kernel, because this is inside the container. For example, I didn't load any other module. There is no the module panel, because this notebook is inside the container without those add-ons. The one you saw previously has more icons. That's a pre-configured through JupyterHub. So this is the default one you just included in that container. So if, for example, you import NumPy, yeah, it's included because it has more than 400 packages. For example, you can import pandas. Yeah, they're all there. Okay. You can work with this container through this notebook. I think that's all for today's webinar.